Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Muhammad Robi Harahap, and for today's video I'm going to be explaining about my end of the semester exam or my finals on numerical methods, which is taught by Dr. Insinyur Ahmad Indra Siswantara. So first and foremost, let's focus and say our prayers to our Almighty God, Allah Subhanahu wa Ta'ala. Bismillahirrahmanirrahim. Alhamdulillahirrabbilalamin. Ar-Rahmanirrahim. Maliki yawmiddin. Iyyaka na'budu wa iyyaka nasta'in. Ihdinas siratal mustaqim. Siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin. Amin. Secondly, I'm going to be explaining my answer on muhasabah, which is the first question on the test. So, reflecting on my experiences in Mr. Da'i's classes, I realized that I have learned a tremendous amount across various domains. His teachings on engineering have broadened my technical understanding and problem-solving skills. But other than engineering disciplines, he also teaches about religion that has deepened my appreciation for diverse perspectives and role of faith in human life. Beyond those things, beyond academics, Mr. Da'i has always imparted valuable life lessons, encouraging me to pursue growth, resilience, and integrity. These holistic insights have profoundly influenced my worldview and personal development. Despite these positive experiences, I recognize that there is still much for me to improve upon as a human. Continuous self-improvement is vital, and I am committed to enhance myself daily. One specific area of regret is missing one of Mr. Da'i's classes due to an oil and gas seminar. So, on the 4th week of class, or 5th week, I kind of forget, I had a seminar on oil and gas that was held by SLB, Schlumberger. It's a worldwide known organization on research and development as a consulting industry of oil and gas sector. So I attended that because I was also planning to join their internship program for the summer, but unfortunately I didn't get accepted, and unfortunately I missed out on the class that day. So in hindsight, I should have informed Mr. Da'i beforehand, and I regret my oversight. This incident underscores the importance of communication and accountability, which I am determined to strengthen moving forward. That was my history, my ups and downs, but looking forward, I have things that I want to improve upon, so I wouldn't be stuck just in place. Looking ahead to the next year, I have set specific goals for myself, including achieving 100% attendance in all of my classes. I believe that consistent attendance will not only demonstrate my commitment, but also enhance my learning experience throughout my academic journey. I have faced various challenges and celebrated numerous successes. Considering my efforts and growth, I feel that I deserve a grade of 80 in this class. Why 80? Because despite me making plenty of videos that are assigned by Mr. Da'i, and also videos that I just wanted to make voluntarily. I've made videos regarding on biography, on what I learned in the classes, also known as my weekly videos. And I also have made videos on NSPDE. We made that using some softwares, and also I have made videos on coding as well. This score reflects my dedication and acknowledge the areas where I still need to improve. So these this is also motivating me to strive for excellence in the future. So despite all that, I have still a lot to improve on, such as uh, my conscious thinking. I didn't feel like I was conscious enough in these classes. There are times where I've zoned out a little bit, and I also need to improve on my academic side of things. I think I have much to learn more about numerical methods, because other than the things that I learned in class, I feel like there are vast criterias, vast applications in the real world regarding numerical methods, which I need to look into more. So that's why I didn't give my score higher. I think 80 is a good range, maybe 80, maybe 75 to 80. Other than that, I think I've explained pretty well. Next is my intention. So there was a case study given to us by Mr. Dai regarding military suspension system, and there were many cases that we need to choose, but I chose one case, the first case, and the purpose is to find the most suitable shock for the STT suspension system to ensure safe and efficient transport of the satellite. This involves analyzing different shock options and their impact on the suspension system. The ultimate goal is to ensure the safety and reliability of military equipment, reflecting our commitment to excellence and responsibility as engineers. The end goal is to recommend the best shock absorber that balances cost effectiveness, reliability, and performance, aligning with budget constraints while ensuring the safety of the satellite during transport. So other than these two goals, these purposes, there are the true goal, which is the goal that looks past worldly things, looks past materialistic things, which is our intention to fulfill our duty to Allah by striving for excellence in our work, being honest and thorough in our analysis, and ensuring that our recommendations serve the greater good. If we can apply the third goal, the true goal, I feel like our other goals would be fulfilled no matter what. If we follow our duty to Allah subhanahu wa ta'ala, He will help us doing everything. Allah will help us doing our other things, help us fulfill our other goals. Next, initial thinking. Initial thinking is one of the Da'i 5 methods. It is actually the second method, the second step to achieving our objective, which is initial thinking. Initial thinking is basically writing what we know, how to do, what is the process, and basically how we think initially. So what is spring mass system? Spring mass system is a classical model used in physics and engineering to describe the dynamics of a mass attached to a spring. So what are the dynamics? We have learned about kinematics and dynamics. We have learned about structures. We have learned about mechanical physics, about machine design, and spring mass system is something that describes the dynamics of a mass attached to a spring. The system illustrates fundamental principles of mechanics such as Hooke's law, which we have learned, harmonic motion, and the concept of force, displacement, and equilibrium. So what is spring? Spring in the system is an elastic object that exerts a force proportional to its displacement for its natural unstretched length. We can see here the F is the force exerted by the spring. It is equal to minus K times X. K is the spring constant, and X is the displacement. So, K measures the stiffness of the spring. If the spring has a larger K, it is stiffer than if a spring has a lower number K. Okay, what is an equilibrium position? It is the point at which the spring is neither stretched nor compressed, meaning the net force on the mass is zero. When the mass is at this position, the spring is at its natural length, and there is no force exerted by the spring on the mass. In an ideal frictional system, if the mass is displaced from the equilibrium position and released, it will oscillate around this point. There are three types of spring systems, which is the underdamped system, exhibits oscillations with decreasing amplitude due to damping. Its beta or damping force is less than its frequency of a natural frequency. So a critical damped system is returned to equilibrium as quickly as possible without oscillating. It has a damping force equal to the frequency, natural frequency, and the overdamped system returns to the equilibrium without oscillating, but more slowly than the critical damped case. So it is given that the mass of the loaded trailer is 1,800 kilograms, and the initial displacement of the shocks is 3 centimeters or 0.03 meters. Shocks available with their spring constants K and damping coefficients B or beta. So there are three types of shocks. There's air coasters, cloud riders, and extreme shocks that we can see that the absolute value of K and beta are as seen in the table. So we will use the IFAV framework to guide which is assessing the possible constraints that could weigh down the optimal outcome for the specified variables given. So in the initial thinking, other than what is given, we can also assess the constraints and variables. So the system needs to avoid oscillatory motion for stability. That is the constraint, and we need to compare given damping coefficients with critical damping coefficients. We can use the differential equation M, the double derivative of x of t, and the plus beta, and the first derivative of x of t, and plus k times x equals 0. And what is the approach that we could use? We could calculate the critical damped value for each shock, and we can solve the differential equation for both the given damping value and the critical damping value, and we can analyze the solutions to determine the best shock absorber. Okay, what is the idealization? Idealization is a step in day 5 which expands upon the assumptions given, or the assumptions that we need to make to further ease our way to solve the problem. We will use the day 5 framework to make calculated and thought out assumptions regarding mass, force, and even modeling as functions or visual models. So the assumptions is the mass and force distribution are uniform, just to make it easier to ourselves, and the shock behave linearly as per Hooke's law. Wait, I'm sorry. We can, if I may charge my device real quick. Sorry for the inconvenience. Let me present in full screen. Next, the shocks behave linearly as per Hooke's law, and the system is modeled as a single degree of freedom spring mass damping system. So modeling, we can model this with a differential equation, which is as follows, and we can calculate the critical damped value. So critically damped, it must follow a set of rules, which is beta critical equals 2 square root of k times m. So with the following, we can just put we can just substitute all of our k's here. Air coasters has a k of 220, cloud riders has a k of follows, and extreme shocks has a k as follows. So we can just apply this to the equation above. So we have the values here. For the underdamped system solution, we solve the differential equation, which is x over t equals E as follows, where WD, or frequency, is as so. For the coding, I've managed making the coding as follows. So we can first import the NumPy, which is a library where it holds mathematical and numerical equations inside of here, so it just makes it easier for yourself. You don't need to write all the codes yourself. You can just import from NumPy, and matplotlib is to plot the graph. So the initial displacement and velocity is put here, and then we can put the linspace, which is the frequency and the step, and the initially is 0. So this is basically the time, as we can display here with t. It starts from 0 to 5 and has a 500 frequency. And then for the shocks, there are 3 types of shocks as previous. And then there are the following k's and betas. And then we can define the critical damping, the underdamped solution, the critical damped solution, and how to plot it. Okay, so under here is just the basic plots, and we can see that the graph that it makes is as follows. Okay, so what is the last question? So Elon Musk's question for AGI, or artificial general intelligence. So who is Elon Musk? First and foremost, Elon Musk is a highly influential entrepreneur, engineer, and inventor known for his role in several groundbreaking companies in technology. Here are key aspects of his background and contributions. So Elon Musk, other than him being the richest person in the world, he is also one of the richest person in the world. He is also one of the smartest person in the world. So he has a vast majority of companies that he's working with or he founded. So I am just going to explain two of them that are relating to AGI. First is SpaceX, who he founded in 2002. Space Exploration Technologies Corporation aims to reduce space transportation costs and enable the colonization of Mars. So in this organization, in this company, he wants to, minimize the cost it would cost to go to Mars, to go to space. So he is doing that by firstly manufacturing the cheapest way to manufacture rockets. So as we know, he is great for his knowledge of coding, his business. That's why he can decrease his costs, and he's also great at manufacturing, at vehicles, and at rocket science. So he is also looking to enable the colonization of Mars. So he's looking for the human race to be able to, migrate to Mars once our world once Earth is fully captivated with global warming. And what is the achievement? To develop the Falcon and Starship rockets, successfully reuse rockets, and has plans for Mars missions. So what is OpenAI? This is closely related to AGI, which is OpenAI is the company for ChatGPT, as you all may have known or used, and we have also used this in our class with Mr. Dai. This ChatGPT, which is co-founded by Elon Musk in 2015. So the description is a research organization aimed at promoting and developing friendly AI. Okay, so what is actually the question being asked? So Elon was asked, if you could ask anything to AGI, what would you ask? This was asked by the reporter in the video that was shown by Mr. Dai. So he responded with, what is outside the simulation? Before that, initially he was sort of thinking hardly. He was finding a way to ask this as nice as possible. And I guess it was sort of like a light bulb moment. And then he asked, what is outside the simulation? So, Elon Musk has this crazy idea that we might be actually living in a simulation. He thinks there's a good chance that our reality is just a super advanced computer program created by some future civilizations. The whole concept comes from this thing called the simulation hypothesis. It is basically says that if a civilization gets advanced enough, they could create simulations so realistic that we wouldn't be able to tell the difference between the simulation and actual reality. Musk looks at how fast technology is advancing, like how realistic video games and virtual reality are getting, and thinks it's totally possible that future simulations could be indistinguishable from the real world. It's such a mind-bending idea because it makes you question everything we know about existence and reality. I mean, what if everything around us, including ourselves, is just a part of a simulation? Some people criticize the idea because there is no actual proof and it's hard to test our proof wrong. But still, Musk's idea makes you think about the potential of technology and how little we might actually know about the universe. Even it's just a thought experiment, it's pretty wild to consider that we might just be characters in some advanced civilization video game. Thank you so much for listening to my explanation. What do I think about Elon Musk's simulation theory? Well, I think that whether it is quite logical that he thinks that due to the rapid increase in technology, the rapid advancement in technology, that makes it indistinguishable in the future to make something that is just like the world. You can make video games that is one-on-one the same as what we see in the world. What prevents us from living in a simulation of a past programmer, of a huge programmer, of a out of this world programmer that could make our lives indistinguishable from ourselves? We could just be in a game. But in my beliefs, in my religion in particularly, I believe that our history is made, our future is also made, and is in a script. It's basically programming, but not by a bigger entity. It's from God himself. It's from Allah subhanahu wa ta'ala. That is, quote unquote, our programmer. Allah subhanahu wa ta'ala could make our future and he could also make our past. So that is it for my explanation. Thank you so much. I'm sorry if I had mistakes in my wording. I could make mistakes. All of the perfection belongs to Allah Subhanahu wa taala. Assalamualaikum warahmatullahi wabarakatuh.